Is shallower really better? How deep should we actually be needling? So one number built an entire philosophy of skincare, a 210% increase in collagen from 0.2 millimeter needling. And it's the reason people are told shallower is better, you don't need to go deeper. The problem is that when I went looking for that number, when I went looking for the study behind that number, I couldn't actually find it in the research. So today I'm gonna answer that question. Is shallower really better? How deep should we go? And where does this whole less is more idea actually come from? And furthermore, is less really more? So if you've researched microneedling, you probably hit the chaos. One person says, oh, you don't need to go deeper than 0.25. Other people say, never go deeper than 0.5. Other people say, if you're not going 1 millimeter at least, then you're not getting any work done. How do we cut through all of that confusion? And furthermore, where does that confusion actually come from? Well, the idea has a real source in the microneedling world, and it's based on, this book right here by Dr. Lance Setterfield. And I do want to be fair because this book does get a few things right. But the big claim in this book, shallower is better, does it really hold up to the science? What does the science say? And what about his own sources that he bases his book on? Well, let's talk about that because there's a lot going on here. So first of all, I do want to tell you there's been a couple of studies about depth, and what they have shown is that when needles get to a certain depth, that is the depth that those needles work in. So there was one study where they needled at 0.6 millimeters and they found that there were changes to the dermis at that level, at that 0.6 millimeter level. They started seeing actual changes to the dermis. What that kind of shows us, is that how far down our needle goes kind of matters to the kinds of changes that happen in our skin. And I do think shallow is good, right? It helps with product absorption. It helps with glow. It helps with the fine lines and the surface smoothness of your skin. So where does our collagen actually come from? Well, when we needle, collagen kind of goes up everywhere, right? On the surface level of the skin, you're making more of that collagen type 7, collagen type 3, right? As you get down into the lower levels of the skin, you start seeing more collagen type 1, right? That's that structural collagen. And so the idea in microneedling is to kind of reach wherever the collagen lives, right? So they try to get down into the reticular dermis because that's where those fibroblasts of your structural collagen actually are formed. Okay, so that's the idea behind the science of why we needle a little deeper, needle into the reticular dermis over just kind of staying at the surface on the epidermis. Setterfield puts forward a different kind of claim. He says if we needle shallower, it's not the fibroblasts that do the work, it's actually keratinocytes that do the work. He says the keratinocytes will amp up and then they will help fill collagen into the dermal epidermal junction, which lives kind of at the bottom of the epidermis and at the beginning of where the dermis starts. But the science actually says collagen gets made a little deeper where the fibroblasts live. There are studies that have biopsied skin after microneedling, and what they have shown is that the activation actually happens right around where the needles land. So if the needles are going 0.6 millimeters or 0.75 millimeters, all of that collagen work kind of happens around the injury point. So how far the injury is into the dermis will start that amping up of collagen and elastin production around those injury sites. So Setterfield's theory says the magic happens on top, but if we look at the actual microneedling studies, and there's a whole corpus of microneedling studies, they do show that the magic is actually happening kind of all over in the dermis, not necessarily the epidermis. So when they biopsied the epidermis, what they found in those studies, and here I'm really looking at one study that mainly did this because there's not a lot of studies that really actually biopsy the human skin afterward. This one did, and what it showed was nothing was happening in the epidermis. All of the stuff that was happening at 0.6 millimeter depth needling was happening in the dermis itself, not in the epidermis, and it was matching how far the needles went down. But I do want to tell you that deeper isn't always more, right? In all of the studies where we've seen needling happening looking at 1.5, comparing it to 2.5. We don't have a lot of studies like that, but we do have a couple of studies like that, and they have been small. But what do they show? They actually show that once you get past 1 millimeter to 1.5 millimeters, that little range in the reticular dermis, you don't see a lot of gains in collagen. You just see a lot more inflammation, a lot more downtime up to a certain needle length, and then you don't get any more gains. There's no more collagen, no more elastin. When I look at the studies, what I see is, oh, they reach the reticular dermis around here. That makes a pretty good gain, and then nothing happens past that point, which makes sense to me based on the science and all the scientific literature I read on this. That makes sense to me because, right, we're reaching that reticular dermis where those fibroblasts live. We're waking them up. They're laying new collagen. Go any lower and it doesn't matter. Like there's nothing else to get to. We just need to get into that reticular dermis. So where does his theories come from? How does he support the theories in this book? Because people cite this book as if it is like, this is what we should be doing. But I wanted to see, what does he base his ideas on? Like, let me look at his studies, because he has citations in his book of where he bases his ideas on. And the first pillar of where he bases his ideas on is fetal healing. So this is support for why he says we need to work on the surface. He says that the best kind of healing happens without inflammation. And since fetal wounds heal in the uterus without any inflammation, they heal better. They don't get scarring. They don't get tissue overgrowth. They don't have all of these problems. So we just need to reenact that in the adult setting. But the problem is the study that he bases it on actually says, like, adult skin doesn't behave in this way and never will. So it basically showed that when they grafted adult skin onto fetal skin cells and they made an incision on that adult skin, it's still inflamed and it's still scarred. Because even though fetus skin doesn't scar in the womb, that's not how adult skin works. Why he uses that to support his idea, I don't know. The truth is that it doesn't transfer to our face. Adult cells scar no matter where you put them. Even if you put them in a fetal environment, they're adult cells, they're still gonna scar. The second thing he says is that we have to watch out for collagen-eating enzymes. One of the things that he rested this on was a study about surgical wounds in pigs. So he pointed to this pig study, and the pig study showed that there were a bunch of enzymes that spiked. Collagenase was the enzyme that spiked, and it does naturally spike. Listen, when you needle your skin, you release all kinds of enzymes, and one of those is collagenase. It chews up dead and broken collagen. But Setterfield is afraid that this is going to chew up our good collagen. It's just going to keep eating collagen. And yes, he's right. It does briefly go up, but all of the studies have shown it also releases something called TIMP3. And TIMP3 actually protects your collagen from being further broken down. So it allows some of the collagen to get chewed up, the unhealthy stuff. And just before all of that collagen is eaten up, TIMP3 comes in and stops. It protects your other collagen from getting eaten up. That's what the studies have shown. That's what the biopsies have shown. The biopsies have also shown that inflammation actually starts to go down. All that says is just make sure to space out your treatments properly and you'll be good, right? You can go deep. Your collagen is not going to be destroyed. And then the other third thing he rests it on is that 210% spike in collagen after 0.2 millimeter microneedling. It amped up keratinocytes in the skin, and those keratinocytes helped lay new collagen. And so that's the way he says that it will work. But the problem is it comes from a lab analysis that was never actually published in a peer-reviewed journal. So I went looking for this original study and it was never published. It was never peer-reviewed. I couldn't find it. But I did find a study that was exactly like it. And this was by a German team, Schmitt and his colleagues. Guys, I'll put a bibliography in my Patreon with all of the journal articles that I looked at. I looked at a ton for this one. So, and that'll be for free. But Schmitt and his colleagues, they published this paper in a PLOS ONE journal in 2018. So this is an actual peer-reviewed journal, and it ran essentially the same exact experiment that Setterfield bases this on. And what it showed was something completely different, right? It was a human skin model. It was needled, and then the genes were measured. And what it found out was collagen III, collagen VIII all went up, but there was actually a release of that TIMP3 that protected the collagen. They did not find a 210% increase in collagen VII. There was none of that. They didn't find an uptick in keratinocyte activity. They didn't show that jump or anything. Nothing that he said that was going to happen actually happened in this peer-reviewed study. That's important because he bases his whole argument on that. He keeps talking about this study and he bases a lot of his argument on that. But the problem is, when they did the same study and they published it in a peer-reviewed journal, the results were not the same. So that's important. That's a pattern. Fetal skin, pig skin, a study that was never published, like all of his arguments for shallower is better rests on studies that are not actually about microneedling. They're not actually about adult skin at all. And they don't show, when they're done correctly and in a lab, they don't show the same results that he's pointing to himself. And I want to bring this home. I don't want to just trash his book. I'm not saying that he has a bad book. I think it's there's a lot of good advice in here. But I will say that even his clinical pictures don't match his results. If you look through his clinical data in his book, it shows him needling at 1.5 millimeters, at 1 millimeter, at 0.75. Okay, he doesn't even do that in his own practice. I'll be straight with you. My sources are not perfect either. They're often small. Some have industry money behind them. And I'll tell you that every single time. I always say, hold on, there's a caveat, right? I try to just bring you the facts and what I find when I look at the research. But I also examine the research and examine books like this because I don't want to just take what one doctor says as like the way to do things, right? Because that's not good practice. But my point is that it's not one study. One study is not flawless and it's like, oh, we rest our, it's that all the studies actually point in the same direction, and that's away from what Setterfield says, right? That we need a needle to the reticular dermis. Going past that reticular dermis is pointless. It doesn't do anything for our skin, but also staying up above that reticular dermis doesn't help with anti-aging. It helps with other things, just not anti-aging. So that's what the breadth of research says. It goes against that book. Match your depth to your goal and you're going to get better results every single time. So let me know in the comment box, did you like this video? Would you like to see more videos like it? I love to hear what you say. I love that some of you are on fire for the research because I am too. And I'll see you next time on Glow Up with Shelly.